Welcome to IEC, Becoming an Engineer, where we connect engineering education research with real-world practice, academia, and industry. Our goal is to create an inclusive space for dialogue, collaboration, knowledge sharing across the engineering education sector in South Africa, positioning our unique challenges and innovations as a key voice in the global engineering education conversation. We explore the challenges and opportunities of engineering education in the global South, while linking our experiences to the broader international landscape. Whether you're an academic, industry professional, or a student curious about engineering education and its meaning for your future, this podcast offers meaningful discussions that go beyond research papers to unpack practical strategies for positive change in engineering education spaces. Join us as we bring together diverse voices, bridge some perspectives, and reimagine engineering education for a more connected and impactful future. So in today's episode, we're speaking with Professor Corrinne Shaw, a researcher and activist whose work invites us to sit with discomfort. Corrinne's background in engineering management and having a strong systems perspective allows her to challenge taken for granted assumptions in engineering education, and this opens spaces for deeper reflections on power, inequality, and transformation. Being rooted in the South African experience helps Corrinne to confront the complex legacies of apartheid and ask the difficult questions about who the engineering curriculum is really serving. This is not a conversation that's about surface level changes in classrooms and institutions. It's about reckoning, responsibility, what it means to teach and to lead and to do both these things with integrity in the context of South African education is Professor Corrinne Shaw, by our complicated histories, a career that is woven between engineering management, focusing a lot on systems thinking, into engineering education, and how we communicate some of these things to engineering students learning about systems. I recall one of my first encounters with systems engineering of any kind was early in my career at a power station, where systems thinking, this idea of zoom in, zoom out, how is information kind of passing through the different levels of from a valve up to a subsystem, up to the whole big plant, etc. That was something that I was trained at technically quite early in my career. And I suppose it took me surprisingly long, and almost embarrassingly long, to realize that that same thought process, similar tools, could be applied to any system, whether we were talking about human beings in the community or educational institutions, again, as systems with inputs and participants and outputs, etc. And Corrinne's way of examining these things, framing these things slightly differently, I always find incredibly thought-provoking because it makes me. I can be a very nuts and bolts engineer. I suppose I can work at the level of the component detail very comfortably, but that makes it super valuable to have somebody who forces you to zoom out and think a little bit more systematically about everything that's going around you. And so hearing Corrinne talk about that, hearing her share her experience at UCT, which kind of overlaps at mine, but is structurally so different, is again like thought-provoking in a way that I found tremendously valuable.
Yeah, that's really interesting, Ruben. I would not call myself the nuts and bolts person. I definitely resonated so strongly with her systems perspective and how I think she comes in from a management side and then she looks at everything through that systems lens, which is maybe not something that we develop well explicitly in our engineering degrees. I've been to many aerospace conferences, and often at those conferences they talk about how systems thinking was developed by aerospace engineering. And really, I think if you trace it back, it's biology. It comes from that discipline. So for me, what was really interesting, I think in general, this kind of like conversation around engineering education and the Reese's lenses that you can bring in was around how to think about the curriculum as a very complex, constantly changing, constantly moving system. And of course, doing research on all of these different elements, and then having that systemic kind of overview that she has gives you a strong insight into all of these moving parts and understanding how they might influence each other or act upon each other. And I think for me, this was interesting, especially because if you think about an aircraft as a system, you also don't want to disconnect when you're designing the engine from the wing, from the control systems, etc. You want to design all of those with some level of integration. The nice thing about an aircraft is at the end you've got a final product and off you go. Whereas the curriculum is constantly changing, and each of the elements, the engine, the wing, the control system, has a very strong subjective argument constantly. And I think that's where engineering management also becomes really interesting, because it's about people in spaces in relation to each other. And I think that was really interesting to hear Corrinne, her journey through that and how she's applied some of these ideas in the work that she's done.
Absolutely. That the idea that our inputs are human inputs who are constantly evolving, and our outputs are also human outputs
Yeah.
who will have these different perspectives on the world. Whereas you're right, like when we design aircraft, engines, etc., air is air. If I know the temperature and the density, I've got everything
Yeah.
about it, right? It's relatively simple to then model that as part of a system. But, you can't describe a student with a small number of variables,
No,
and no two students are the same.
absolutely.
So that's where the complexity of the models becomes interesting, fascinating,
Yeah,
gives us work.
absolutely.
Corin, we'd like to start at the beginning. Can you tell us a little bit about your journey into the engineering education space and how your background in engineering management and systems thinking has shaped your approach?
Thank you, Ruben. And thank you for that introduction. I started working in engineering management and running a master's program in engineering management, which was very much focused on interventionist research. It was about trying to answer the right question, to find out what was going on in order to answer the right question, and then look for leverage points to create interventions and then implement those interventions. So it was very much a linking of theory and practice. So it was most of the students involved in the were doing their master's degrees were engineers who were working in practice. So they're working in contexts that were layered in terms of the technical expertise that the students required, but also the social issues that they needed to engage with, the cultural issues in organizations, and also, economic and other influences. We took them through a process of understanding what these factors were that influenced the problem that they had identified, how those systemically interacted, and then to create interventions. So my research also followed along, not so much focused on the actual problem solving process, but on how students learned their way into that kind of problem solving, how they learned to deal with complexity. So it was in some way not too much of a shift into engineering education, because engineering management, my research there was about how students learned how to manage complexity, how to think metacognitively, and also to be able to separate themselves from context but yet understand it. So that learning process was what helped me shift into engineering education. I was really looking for a community of people, and engineering education provided that, because there was this organization, the Center for Research in Engineering Education, which actually had, at that time, it had engineering educators, engineering education researchers, but also STEM educators, people from physics education and maths education. So that's how that shift came about.
Yeah, Corinne, I think it's so interesting the way you describe that journey and how that those connections are actually made and how you got to engineering education. I wonder if you want to talk a little bit about the actual research the research you started with and where you are now in terms of what you focus on.
I really enjoyed that work that I was doing in engineering management because you were working with people who really understood that they needed to learn their way into understanding a problem and engaging with a problem. So because they were mature students, the kind of theories that I drew on for learning was around adult learning, experiential learning, learning from practice, action learning. So it had consequence, it had immediate consequence. The work that was being done by students was done in organizations. So the work that I was supervising was real problems in organizations and other corporates. And it was about also, as I said, designing and implementing interventions. So there was definitely a practical action component. I see it as a shifting from an abstract world of theory into a practical context, which is a concrete context, which you have to make decisions. It's got consequences for people. So the research is interventionist and consequential, whereas the kind of research that you do in engineering education mostly stays in that theoretical abstract world in some senses. So the problems in engineering education may come from a real world context, but it really involves action research where you design interventions and you apply it. Often we separate the theory and the abstraction of the understanding. We separate that from implementation and don't always do research on the implementations.
Mm. Yeah, Corinne, I mean, this is so true. And I mean, what really is resonating for me is I'm sitting here thinking, I wonder if one of the reasons that we don't find that often is the complexity of how to do that, right? So there's an aspect of, and I'm recalling a conversation I had in my early years as academic where we spoke about how should we think through engaging or developing the design element for students, like how should we think about it? And we had an internal debate around, should we give them a problem and like skip that part so they can get to the design and building part? Or should we let them stay in that beginning part to really grapple with who is it designed for? Like, that the unclear, uncertain elements, the real world elements that you're kind of speaking about. And although majority of us said, no, we should keep them in that first bit, none of us really knew how to do that because it's not easy to facilitate. It's not easy to assess. And it's deeply uncomfortable, both for us guiding the student and for the student, because it's a place we kind of have to, it's not as straightforward as now we're doing integration and we do this step and then that step and then you get an answer. It's a bit more nuanced, a bit more, I don't know, conversational elements that needs to be had or relational elements that needs to be taken into account.
I've got a whole suite of methodologies, of tools, techniques, theories for this kind of research, for understanding the whole of it. We refer to the processes as problem formulation. So there's a whole process of problem formulation and understanding what the right question to ask, what that is. Because of course, we all spend a lot of time solving the wrong problems. So we often create an intervention which solves another problem and doesn't actually solve the problem that we identified initially. So that problem formulation is a process, which if you use systems theory, and it's a systemic process. So you look at, all that's involved. You look at different perspectives of the problem because, you can take a design problem and you can take a technical lens to it. You can take a technical perspective or view of it. You can take a social view of it. You can take a multi-stakeholder view, like a community view. You can take an individual view. So there are all ways in which, and lots of tools and techniques and methodologies, as I said, that we can use for the problem formulation process. And then as the next phase, looking at, there are often a range of interventions that you can design. So you need to find the intervention that has the most leverage. So you look for you look for the drivers in the system. So, you model it systemically, you look for the drivers in the system, because the drivers are normally which will impact upon, create the outcome. So if you invest in, so it's always about making decisions about where to invest your resources and energy in the to make the intervention so that you can get the best possible outcome. So that has a knock-on effect on other variables in the system. So there's, I'd love to set up a workshop in engineering education at some point where we engage with, and these are accessible to people. It's not easy, because dealing with complex things are never easy, but there are ways in which you can guide people into a process of doing this without it having to be. So, of course, you can do research about work like this, but you can also have a structured process of just creating interventions that and then measure it or documenting it.
Yeah, absolutely. I think, and I mean, the lens that you're bringing to this from your background is so incredibly valuable and so unique. I think it's not often that we find people in this space with that kind of experience and value that they can bring.
It's a lot more common and popular in management programs, for example, like at the business school.
I wonder in general if you had to think about the way that we organize engineering programs and engineering curricula, elements like problem solving. I think we've spoken about problem solving, but there are other elements, of course, that has the same kind of unbounded concepts that we're working with, and also elements of not having open-ended ways to approach it, right? So I think that's often where we grapple, both to facilitate it as learning for the students, but also to do it ourselves. So I wonder if you have any kind of insights when we speak to that practice itself, like how we do that education.
One is to be careful with dealing with too much complexity at an undergraduate level, where people are learning the principles, the foundational ideas, the introductory knowledge, the threshold concepts, and so on. So they're only getting access to ways of thinking about engineering and about technical knowledge and so on. And I mean, there's been a lot of research around the different stages or phases of cognitive development and maturity models and so on. And it's quite difficult for students to deal with unbounded problems, or and I think it's because they are, they first require the kind expertise to understand the world. So whether they're dealing with, and I mean, at undergraduate level, we also deal with systems, but we deal with technical systems or systems that are physical systems. So they're designing a physical thing. When we talk about systems in a problem-solving space, or in our practice as engineering educators, our problems are complex and they're socio-technical or they're social. When we're looking at how students learn, those are generally social problems we're dealing with. But some of the stuff that we're dealing with is socio-technical. And it's for ourselves, we're dealing with these complex problems. So we need these kinds of ways of framing it, understanding it, and deciding on interventions. But at undergraduate level, they still need to, understand what a physical system looks like. So to take them into a conceptual understanding of a system is really difficult to do. So I think that it works well when you're working with mature students, that some things don't work, that some of the ways they've been trained, some of the ways that they view the world doesn't work to solve the kinds of problems that they encounter. So then they look for they actually seek out other ways of understanding the problem or what they're engaging with. So with our undergraduate students, it would be almost unfair to provide them with too much unbounded problems. We can do that. We do that in little ways, like looking at human-centered design, for example, where where they've got to We give them a very small toolbox in terms of being able to understand the problem from the user's perspective in order to design a response to it. But the toolbox for them is very small, whereas more mature students and ourselves, we can potentially have a larger toolbox because we've got our technical expertise and we can draw on it, and we understand the nature of we have a better understanding of the nature of our problems than our undergraduate student.
Yeah, no, I mean, this is really cool. And I agree. I think the exposure to complexity, we need to be mindful of how we do the exposure and that it's like gradual exposure.
Yeah.
I'm of course very aware of the two modules that I'm a big fan of that you have at UCT with Bruce Cluth, the engineer in society and engineer in business. And so what really struck me about those modules is how you weave in ethics, politics, history of the context in a very interesting way. And so I'm curious how what you've mentioned already ties into how you've thought about that module and how that runs, because it feels like that's a really nice example of an early exposure to complexity for the engineering graduates.
Yeah. We do little bits of it in first year because we do Engineers Without Borders project. So we start introducing human-centered design into first year. Brandon and I designed it so that they do a semester-long project in first semester and one in second semester. So the one starts out with, design specifications. You need to design something that does something. Whereas with the Engineers Without Borders project, and we used to have our own version of this before, they've got to be designing for people who live in a certain community, have certain needs and so on. So we do start introducing open-ended, approaches in first year. And then we pick it up in third year again. So the two courses, they're two substantial courses. They're both 16 credit courses. The engineering business, we designed it so that it looks at the context in which the engineer would work. So it's the world of work kind of course. And the engineering society course is the world outside that work that the engineer needs to engage with. And there's also has consequences for the work that they do. So it is about providing context. And of course, the knowledge structures in these kinds of courses are very different to the technical knowledge. The assessments are different and so on. So for students, we're very aware that we're introducing them to a different discourse. So we try and scaffold them into that process. We've been training our tutors. We ourselves have tried to scaffold that. It's the kind of course we constantly need to reflect on. What worked, what didn't work. How can we adapt our work? And that has informed some of the research that we've done. We've looked for resources locally, but we don't want to always take something off the shelf that comes from the global north. So we've looked for resources locally. And because of the absence of resources, we've recognized we need to do some of it ourselves. So that's why, it's informed our research in this area.
Yeah, I wonder if you can share a little bit about that research. I know Bruce in his podcast episode spoke a little bit about that, and we went in a completely different direction. So I'm curious if you want to share, because I also think the way you've approached the module and then the research that subsequently has come from that, I think that's been really meaningful. I want to say for those of us that have read it, both on a personal level, because it's in our context, but also from how we might think of including elements like these contextual elements like ethics and politics and our history into our classroom.
Yeah. There's a tension in engineering. It's sometimes not fully spoken about or recognized. There's a paper by Johnston, and I've no doubt that Bruce probably mentioned it, called Engineering as a Captive Discourse, because engineering is being taken over by, in some way, various interest groups that, we think of engineering as being in the service of the economy or in service of large corporates and so on. So that's on the one hand, there's engineering has been seen as having a particular purpose in terms of development in a country. But on the other hand, what it's done is it's taken engineering away from solving the kinds of problems that so many people have in a context like South Africa. It's the day-to-day experiences that people have, their access to economic opportunities, and so on. So we often, when we think about the kinds of things that we want to design, most of our students want to design, rockets, things that go, travel into space. They want to design robots. They want to design Formula One cars. They want to design things that would only serve very few people in the population. They also, you need the kinds of things that many of them want to design require huge capital investment. So, but then on the other hand, not many of them talk about the kinds of, there are some students who talk about, they want to improve the infrastructure in their communities, because they don't have a regular electricity supply and so on. So some students have that kind of social sense or sense of the value of engineering within their social context. So it's so because of this kind of tension in engineering, we've had to consider, when we offer a course like Engineering Society, what are we saying? What message are we giving to the students? Are we saying that we want you to become a social activist or an engineering activist? Or are we saying you need to, have the interests of the community above other kinds of interests? We decided that we needed to give students the option, say that there are different kinds of engineering identities. You can be the person who designs, robots that do all kinds of things, or you can be an engineer who looks at, providing renewable energy at very low cost, for example. And part of understanding your context is understanding where we've come from as a country, and that history in South Africa is very much a colonial history, and of course, apartheid is a form of colonialism. In fact, it's the United Nations included, in 1960, included South Africa in their anti-colonial publications or documents that was the intention to liberate people and to get rid of colonialism. So we've come from that kind of history, and it means that some knowledge and ideas and identities are privileged above others. So, as part of understanding that history, we've had to walk the journey ourselves, because we're not historians. I don't think. I mean, I last did history in Sem 6, which was a while ago. And I don't think Bruce loves history, but I don't think he actually studied history. He certainly didn't do it at university. But we wanted to find out, for example, what happened in engineering during apartheid, and not just during apartheid, but prior to that, and also during apartheid. And we discovered certainly that there wasn't a lot published about it. We found some articles, not a lot published about it. So we decided to do a research project ourselves. So we interviewed people and we wrote a paper on engineering under oppressive regimes, which describes the experience of engineering during apartheid in South Africa. We're now busy with a paper that looks at decolonization in South Africa and what that means for engineering education now, given this history.
Corrinne, I'm thinking about this idea of how one can't separate grand engineering projects from the politics of the time, whether we're thinking about things like the Hoover Dam during Depression era America, or if we think about something like the Concorde and the British and French aerospace industries post World War II, where so much of the motivation in either of those was countries wanting to do politically we really want to advance this particular sector from whatever kind of ill fate had befell it just before, and how they were able to do that, and how those things show up in our engineering curricula primarily as sort of as the technical marvels, as it were. People are showing like, oh, look at this magnificent dam that was the first of its kind, or the fact that Concorde was a supersonic passenger liner. But exactly what you're saying, that these are things. Concorde was an airliner that only a very small segment of the population who traveled by air, which is already a very tiny segment of the population of humanity, ever got to see the inside of. So I suppose the question that's kind of bouncing around my head as a person who tends to stay more in the technical side is thinking about the projects, the engineering projects that are really related to the less served communities, and what are the technical advancements that are happening over there that we want to talk about in forefront. And as is going on at the moment in the energy sector, all the work that is happening around, whether it is an embedded photovoltaic system for your home, or things that scale up a little bit, where a village could now have a microgrid. There is some incredible technical engineering that is going on in those spaces. But because it serves it's not the gee whiz where, we're putting a rocket into space and a man on the moon kind of thing. But how do we as educators look into those and start drawing these closer links between, as you said, the human-centric design and what's happening that's really important in a space that just isn't familiar to the student who's had the privilege of a middle-class suburban background.
Yes. I mean, you're just underlining the fact that that these decisions are inherently political and serve particular interests. And of course, those are published as these great marvels. Look at our wonderful engineering expertise. Look at our, look what we can do. And it's that is then becomes an aspirational thing for engineering students. And they don't aspire to necessarily doing the other things, but we can make that difference. We can actually draw on these kinds of examples, and engage with these conversations with students about how interests are served, or why how decisions get made about what kinds of projects engineers get involved in.
Definitely food for thought, and absolutely something for those of us who are, as I said, a little bit more technically focused to think about how do we span the technical solutions for the everyday versus the more grandiose things, and the things that are necessary but not necessarily so grandiose. What would you like the other engineering educators out there, particularly those who are trying to do transformative work in spaces that would be more constrained for whatever reasons, their political history or the economic state of those institutions? What are some of the things that you would want them to think about in relation to these changes?
It's not easy if you, as you say, you don't necessarily have the experience of engaging with these contextual issues or thinking about engineering as political. But I think that I would like people to consider the different lenses with which they can explore the engineering world, but also that when they make decisions in terms of which examples to use, or understanding where those come from, how those came about. Because it's one thing, we're not I think when we talk about curriculum change, we're not asking people now to just choose local examples. We also would like people to say, actually, the powerful interests that decide on what choices that we're making in terms of where money gets spent by governments, or where, when they're working in that our students are going to go into organizations where they possibly need to critique the kinds of work that they're doing. So I think it's just to say, for educators to reflect, and possibly, we should provide some help and guidance and support for that kind of reflection. Because I was aware even at the CEFI conference recently, that and that's a conference of engineering education researchers. For some people, thinking of engineering as socio-technical is still novel. Because they're so steeped in the idea of engineering as being purely technical, being neutral in the sense of apolitical, so yeah. So I think it's really an invitation to ourselves to help support engineers in that kind of reflection, but also start the conversations, and invite people to conversations. It's just that in our experience in the past, people have been quite resistant to it. You see, I think, Ruben, the Hoover Dam example and the Concorde, I think are really great examples. And that, it's a kind of way, maybe we need to work with people like you. I think if we had a conversation with you about, and we try to find a middle ground, we could actually learn from each other and develop a set of resources.
I mean, Corrinne, what's so interesting, and I think the reflection on, for many, and I would agree. I mean, I also just came from conferences in Asia and Southeast Asia, and it's the same. Like, some conversations really strongly focus on that socio-technical element of an engineer, and some are completely blind to it still. And it is quite interesting. And perhaps our context makes us very exposed to that, or perhaps different context, like people moving around in different contexts makes you exposed to that. And it is a difficult thing to deal with. And I almost want to say, even when I consider how we structure curriculum, how we do accreditation, how our universities are set up, there's almost a systemic element. And I can't tell, and maybe with your insight from engineering management and the combination of the insights that you have, I can't tell if it's because of things operating in silos or things have just always operated in the same way, and so things continue to operate in that way. But it does feel like there's, at least in the last couple of years, a stronger drive to be more holistic, to be more inclusive and more integrative than there has been in the past. And I don't know if that's something that you're also noticing.
Look, I mean, the roads must fall and the fees must fall protests and the science must fall. I think that has created a kind of, certainly not so much in engineering, but in other fields, a huge conversation about and scholarship around what decolonization means, and to us in a kind of post-apartheid era, given that what's happened is that, as a country that was colonized, we were introduced to certain ways of thinking, doing things, knowledge structures, and those things have been valorized. That is the standard. And if we do something different from that, we're going to drop the standard. So what happened is we've gone from colonization, coloniality and colonization, to neo-coloniality. And, so we've taken those same structures of how we do our curriculum and how we do our assessments and what kind of knowledge is included and excluded. We've taken that and we've just continued with that. And there's been very little interruption and disruption of what existed before. So it means, and I mean, people, globally say that we're teaching some of the same things that we taught 40 years ago. And I mean, 40 years ago, we were really in the, completely colonized, and it still is, things are still have not changed significantly in some ways. So, but in 2015, there was a challenge to that. So it did create a conversation around and some scholarship in engineering around that. But it didn't shift significantly into the way we structure our curriculum, the way we honor context and the language and different experiences that students bring into classroom. We're doing something similar, even though the actual cohort of students may look different and have a completely different experience. The shift is a small shift. It's not a paradigm shift. We've always thought of, the kind of educational activism that we do is working in the small spaces, working within the spaces and creating those spaces. And I think that, there's been a movement. I mean, you've been very much part of that as well, Alani. And it's been, there's new conversations happening. And we're actually looking at ourselves locally as a continent, not just as a global entity, but also just there's certain concerns that we have. There's certain ways in which there's certain historical things that we have in common with other countries on the continent that can create a common conversation for effecting change. So it's so yes, I think that there is some change happening. It's just that I think we need to talk broadly with people, and I think that we in Cree as well, we making a shift in terms of understanding of our need to engage with a community of engineering educators beyond our own. There's, I think the idea. I mean, I'm really excited about this conversation that Ruben has slotted into as well around the understanding the political and social nature of technical decisions or technical systems.
Absolutely.
So I think that is something, because it looks to me like that can be, we need to look at the shape and size of the space that we want to have a conversation in. I think that we've got a lot to learn because our focus now has been in the kind of socio-technical, but more the social domain. And if we could learn from our colleagues who are more focused on technical systems, but are interested in, the fact that there are different perspectives, different stakeholder views when you're making a decision about where to put your distribution line. If we can have those conversations where we're learning that more technical from them and they learning more social from us, I think that would be a good way to collaborate. Where it's not just a transfer, it's an engagement and transfer both ways, not in one direction.
I think, what you're saying about how Cree is also starting to move and work in a different way where there's more connection points externally. And in general, I think the whole conversation around the complexity that we're grappling with, the transformation we're hoping to see isn't something that we can do alone. I heard recently someone speak about we should actually just focus on the SCG number 17, which is the partnership one, and then we will get to all the others if we focus on just building those strong relational partnerships and thinking through collectively how we want to see that transformation move. I am curious because I know in some of our spaces, not just in South Africa, but beyond South Africa, the system often pushes back. There's often a lot of colleagues would feel isolated in this idea where they start wandering more into the social side of the socio-technical balance. And it's often not so prioritized. It's often seen as a nice to have, not critical to. And I'm wondering if there's anything that comes up for you in terms of how we go forward and make sure that we find these cracks in the system to make sure that the message can come through, that there is the shift, and it has to be both. And it has to be us together, because you can't suddenly expect me to be more than I am and you to be more than you am. But both of us together bring up something quite unique if we work together.
Yeah. Okay. So I want to respond to that in two ways. The one is just to mention that when you talk about the cracks, it's Pam Christie spoke about, and she's an educator, was at UCT and Australia, and she spoke about moments of fracture, where you have an opportunity to kind of work within the cracks or the fractures and just open it up a bit and have those conversations. So I think that that idea is a useful one for people generally. But some of the pushback is about that there's not enough time for the technical systems. That there is that students need to, they need to get a really strong grounding in engineering knowledge, technical engineering knowledge. And I don't push back against that at all. That is necessary. It's absolutely necessary for an engineer to learn how to understand technical systems and to understand it, build it, maintain it, and also to innovate for a range of different stakeholders. So that is really important. But I think that we can't decontextualize engineering as well. So we have to find a way to for people to feel comfortable with actually pushing into those cracks, is to find those moments of fracture. We're doing work in the first year space. So I've got a research group in first year, and it's myself, it was Brandon, Collier Reed, and Malaboho Gwepe, and Kate Leroux. And we've been working around with the notion of moments of fracture, but doing it not only with modules like sustainability and ethics, but also in the technical modules. So our intention with this work that we're doing in the first year space is to have some examples of what we did and what worked, so that we can share it with colleagues as a way of inviting them to do something similar. Because I think that many people wouldn't know where to start. So we're not saying we want to redesign the curriculum and take out the technical content and put more social content. That's not the message that we want to convey at all. What we are saying is that there are going to be many moments when you're talking about a particular, for want of a better example, a particular design, and then you can, introduce the consideration for the users. So there are ways in which to do that, but our intention is to actually have some examples, practical examples about working in class.
So I was thinking about what you're just saying about how do you integrate some of these things, and how our students often take slightly different things away from our classrooms than what we intended. One of our current third years came and asked me a question. He said to me he was asking me this question because he felt that I was very safety focused in terms of engineering. And there's me scratching my head. I'm the person who probably works on the more dangerous end of things when I'm doing hands-on stuff. And then it kind of occurred to me where he was coming from, which was this: when we were doing practical workshop stuff in the second year course, I was absolutely headstrong about, you are going to be safe. And if a student did something that made me unhappy about their safety practice, I went and shouted at them and threw them out of the workshop without negotiation. So it was this, this weird thing, like, even though it wasn't my intent to teach them about safety in a way that would be examined in a traditional assessment of any kind, but the message that they took away was that I would not tolerate unsafe behavior from them in a space that I was responsible for. So, it's thoughts like that and ideas like that around, we want our students to think about things. We want them to be aware of things. That doesn't necessarily mean that these things show up in the final exam or the final project that the student submits for a project-based course per se. But that we create the kind of activities and we open ourselves to the engagements with students where these things become highlighted, and that a student can't just do I'm only learning about equations and drawings and calculations and the traditional space of technical engineering work. So yeah. So I think one of the big takeaways that I'm getting from how we've talked about this and how, some of the things that our conversation might stir in other people is that one, when people encounter these ideas, that they're going to be uncomfortable at first. And so the first step is that the person's got to kind of just sit with that discomfort for a little bit and think about it for themselves. But then the next step is to have a conversation with a colleague or colleagues who might be thinking about similar things or might be involved in that some way. And then figure out, how does this become a real activity for our classrooms and helps us advance something in our engineering education space. So Corinne's written, there's so much more that she's written. And for colleagues who are interested, there'll be links in the notes about Corinne's writing, along with Bruce, who's been one of our other guests, and that people can follow up and subscribe to this for more conversations about engineering education in the South African context. So until our next episode.